Hi, this is Jacob Cooper, and this is my Physics 1, lab number 4 on oscillation. So, a little introduction. Our goal here is to examine the motion of a spring mass system in which the mass swings in an arc while oscillating on the spring. A little overview. In the experiment, we observed the mass. We took a video of our spring in motion, and we put it into our tracker software, and then we used the data from tracker, put it into our GlowScript code, and we made some computational models. Some key ideas here: Newton's second law, energy principle, work, spring, and gravitational forces. Some of our key formulas here: we have our velocity update formula, kinetic energy, our position update formula. We have the force from gravity, force from spring, and then both our potential gravitational and our spring potential energy. Here's our code, and so you can see throughout the code how we've implemented our formulas that we just looked at. Here you can see our spring calculations. Here we have our kinetic energy, and then our potential gravitational and spring energy, and then our total energy. And here we're kind of doing the same thing in our while loop. And so that's that. Here's our change in energy versus time graph. So as you can see, we had a pretty big time. I think we had like 16 seconds at our time. And also I forgot to note that back here, our the mass of our spring was 0.2 kilograms, and our initial position was 0.251 in the x direction and negative 0.122 in the y direction. The change in energy versus time graph, and then here's our graphs from the x position versus time and the y position versus time. As you can see, our model. Our experimental models and our computational models do differ a good bit, and that could be from a lot of things. It's like it could be an error in our tracker software with like the center of mass, the exact center of mass throughout. Could be factors like drag. It could be a lot of things, but I'd be willing to bet it's from our tracker software. What does it mean? So our questions for the what does it mean is the energy principle satisfied in our experiment? And in our case, it was not satisfied because, as you could see in our graph, our change in energy does not stay at a constant zero. Therefore, the energy principle was not upheld. As for our oscillation periods, for our x position, average oscillation period was around 0.7835, and for our y was around 0.4378. And so this is not exactly what we want. This difference can go on to cause problems in our experiment, which could be partially why we didn't get the results that we exactly wanted. And this could go on to affect the spring constant, different forces, etc. And so